Okay, now I see that we start the broadcasting. And once more, a warm welcome also on behalf of the raw materials team. So now you are entering in the parallel session of raw materials, and we will start with, and it will be presented by Daniel de Oliveira from the Portuguese Geological Survey ERA-Net. And Daniel is also the chair of the EGS Raw Materials Expert Group. And Daniel, the floor is yours.
Well, good morning, everybody. Thank you very much for that introduction, Antje. Let's move on to the presentation because I know time is limited. So with that said, I'm going to start the presentation.
Daniel, you're muted.
Apologies.
Daniel, you seem to still be muted. I can't hear you, at least.
I'm sharing the video. I can hear myself.
I can hear you speaking, but not the...
Same here.
Yeah, I don't know how to fix this actually. Christian, Georgia, any help?
We can hear it. It's fine. You can go.
Nos consegues ouvir a apresentação?
Estou a ouvir tudo o que vocês estão a dizer.
A apresentação, o vídeo.
Hi, Daniel. Why don't you start?
Daniel, you can restart the video maybe because it's not working.
I have started the video.
No, restart from scratch. Because nobody can hear it. Okay, thank you.
And now?
No, still no sound, Daniel.
Look, can I ask then to move on to the next presentation? In the meantime, I'm going to send Christian the video.
Okay, we will do so. Okay? We will do so. I'm pretty much sure that we can solve the problem. So once more, we will start now with the project Mine to Sea. Mine to Sea, as you know, marine projects, and we will get the presentation by Egidio Marino, who is also from the Spanish Geological Survey, and he's supported by the project leader, Francisco Javier Gonzalez Sanz. Okay, go ahead, please.
Well, good morning to everyone. Sorry.
It's okay.
You can see yes. Hear the presentation?
Yes.
Okay, first. I don't know why I'm hearing here. Sorry, I will I will quit something. Okay. Okay, it's better now. So, good morning to all. I am Eugenio Marino. I finished my PhD in the frame of the Mine the Sea project, and actually I will present the speech of the Mine the Sea project called Marine Minerals, Millions of Years, Scavenging Battery and Technology Metals from the Seafloor Environment. First of all, we speak about the project is formed by a consortium of 12 funded and non-funded partners from several countries of Europe and also out of Europe. And the main challenge of the project is to increase the knowledge of the seafloor deposit because they are very important for their concentration of several critical raw materials. For example, cobalt, nickel, manganese. These elements are concentrated in several of these marine minerals. Also, it's important because it's expected that by 2030, 10% of the world minerals could come from the marine minerals, and that's the marine mining industry will increase from nothing to almost 10 billion for this year. Also, it's important because several of the elements listed in the critical raw material list of 2020 are concentrated in these marine minerals. In this slide, we can see that it's expected that by 2050, the demand for several of these elements will increase almost 500%. So it's important to increase the knowledge of this element and their concentration in marine minerals. Actually, the Seabed Exploration is present 2 million square kilometers of contracts considered by the International Seabed Authority for the exploration of polymetallic sulfides, phosphates, nodules, and ferromanganese crusts in several areas of the oceans. So the main deposit we studied in the project are hydrothermal mineralization, cobalt ferromanganese crust, phosphorites, polymetallic nodules, and marine placers deposits. To study this deposit, we used several cutting-edge technology, both on board of the cruises, that's at the labs. For example, on board, we used the last models of several ROV, like the LUSO 6000 and the ICE 6000. And in the labs, we used high resolution analysis performed with microprobe or laser ablation. This allowed to increase the knowledge of the several seabeds. For example, the Moitirra field, we can obtain high-resolution image and samples with the ROV, and also on the top of the tropic, we can see the field of nodules that is in the top of the tropic, and the studies will show the composition of the sample studied during the analysis at the lab. Also, we used new technologies with the GIS analysis that allowed to perform predictive maps in order to know where to find this type of deposits in the European seas. Well, the main objectives of the project are also to identify the metallogenetic provinces that for each type of deposits, know their mineral formation, the area and where are located, the age of the formation of each deposit, and also the genetic models. For example, in this image, we can see in the triangular diagram the genetic model for ferromanganese crust in the south of the Canary Islands that can be formed both from diagenetic, hydrogenetic, or hydrothermal models. So the results can be resumed in several maps. For example, the metallogenetic map for hydrothermal occurrence, in which we can see the presence of the metallogenetic areas near the mid-Atlantic ridge, but also in the Beckark areas, both in the south of the Iranian and in the Aegean seas. On the other end, the metallogenetic map for ferromanganese crust and phosphorites, we can see that this type of deposit are linked more to hard substrate like seamounts, banks, and plateaus. And we can see that there are several good areas like the Arctic Ocean or the Macaronesian area, in which it's possible to see the big areas of in control of these elements. Well, also the project will collaborate with other projects of the GeoERA raw material branch, like the FRAME project, in which we can collaborate in the realization of a sea and land map of cobalt occurrences. And also, the results of the project have been used in several cases of study. For example, a master's thesis on the nodules in the Baltic Oceans, or my PhD thesis on the south of the Canary Islands, Seamount Province. And also it's possible to see the knowledge, for example, for the possible mining of the top of the tropic seamounts. Knowing the thickness of the samples, is possible to calculate a tonnage of each element. Also, the data are being used in order to support the European Commission, for example, with the realization of a pan-European map of energy critical elements like cobalt and lithium, in which we can see that this element can be concentrated in several deposits, for example, nodules or crusts, and that they have different concentration in each of these deposits. Also, the data will be shared with the European Commission in order to support a new blue economy report during these last 3 years. Another important branch of the project is to analyze the present-day exploration and exploitation status, know the regulation, legislation, and the environmental impacts that each country, both in Europe and out of Europe, have for the exploitation and the future direction of the mining of this type of deposits. So the result is to develop will go in order to develop an harmonized mineral maps and data sets of all the data that we collected in 23 different countries in 14 marine regions. We used an harmonized scale of 1 to 250,000. And we listed several critical raw material for all the type of deposits. Here is the resume of the resume maps of all the deposits. We analyzed almost 15 million square kilometers. We found almost 700 of occurrence of the 5 types of the deposit studied, more than 1,100 analyzed samples that allowed to discover that this deposit have resource and economic potential for several elements like cobalt, tellurium, niobium, rare earth elements. These data are also available in the European Geological Data Infrastructure, EGDI, in which you can switch to the Mine the Sea project and select the different type of deposits, and also know, for example, the metallogenetic areas or the predictive area for each deposit. So this is important because the knowledge of these elements allow it to develop sustainable technology, develop the energy transition of Europe, and also to the environmental protection and the spatial planning for Europe. So this is why we, for example, highlight the 14 critical raw material and several maps in which we can we find how these elements are concentrated in the different 5 deposits, knowing the geochemistry, the mean content, the number of samples analyzed for each deposits, and the range of contents for each deposit. One of the results obtained is, for example, these predictive maps for ferromanganese crusts and phosphorites, in which we used several criteria with the GIS in order to find out where are the areas with the highest possibility of presence of the ferromanganese crust and phosphorites. So, for example, in this map, the highest potential are the red and the orange areas, in which is possible to see that it's possible to find these crusts, and or for example, this compilation maps of potential and prospectivity of each deposit, in which is possible to see where are the better areas in order to explore for the future. The results of the Mind the Sea project are being used in order to perform several scientific articles that is possible to see, and their download in the GeoERA Mind the Sea Wix sites, and also it's possible to download 35 public deliverables from the GeoERA Mind the Sea 2 page. So I hope you like it, and thank you.
Thank you very much. Due to the time, we need to use the Q&A box if there are any kind of questions, and I hope there will be. But thank you very much for this very impressive piece of work and the interesting project performed. So we need to move on, unfortunately, and we give another try to frame. So Daniel, please.
Yeah, so apologies for the earlier glitch. I have sent the presentation, so please, Christian. Good morning, everybody, and welcome to Frame. Frame is forecasting and assessing Europe's strategic raw materials needs. Frame is part of the GeoERA raw materials set of projects, and the set of projects that make up GeoERA raw materials, as you can see on the slide, is Eurolithos, MindSea, Mental4EU, and obviously Frame. Now, GeoERA raw materials works on a set of objectives that you can see listed on the right hand side of that slide, and also it is something that has worked over the last few years to generate a series of firsts. Now, some of the firsts that have been done in the GeoERA raw materials is a combined database with data on mineral occurrences and mines, production, trade, resources, and reserves, namely within Mental4EU. It has done the first set of national atlases on ornamental stones done under Eurolithos. Frame has compiled mineral occurrences, geology, and potential for rare earth elements, lithium, cobalt, and graphite. And for the first time, it was possible to make clusters of deposits and also metallogenic areas. Mind the Sea created the first pan-European maps on marine deposits. And obviously, together with Frame and Mind the Sea, we created pan-European predictivity maps on marine and landlocked critical raw materials. Now, critical raw materials, we've all heard about them. We keep talking about them. And obviously, what do they do for us, and how do they play a role in our daily lives? Now, the picture that you can see on the left-hand side of the screen is the famous house, where it shows all the different elements that you might be needing to have all your amenities under one roof. And also the example in the middle, perhaps the most commonly used example right now, is what minerals go into making up your cell phone. However, minerals are not only for these two applications, but are also used in clocks, fireworks, paint, air generators, hybrid cars, photovoltaic panels, even toothpaste. And so these minerals are definitely in our daily lives present in a big way. Now, coming back to Frame and the foundations on which Frame was built. Frame was built on the circular economy, the battery initiative, critical raw materials list, and obviously the conflict minerals regulation, which started or which was published in 1st of January 2021. These are concerns of the European Commission, and obviously all these feed into the European Raw Materials Initiative. The impacts on the mineral intelligence of Frame are as such. One, Frame updated and completed ProMine's Minerals for EU, ERA and European Geological Data Infrastructure datasets on rare earth elements, graphite, cobalt, lithium, phosphor, niobium, and also tantalum. Frame also used the close cooperation and collaboration of the Mineral Resources Expert Group of Geological Surveys to supply extra data. This extra data, namely in the battery critical elements, has resulted in an increase in 60% of the known occurrences that we had in the previous database. So this is quite a remarkable increase in data, and obviously this data is being put to good use. In terms of the phosphate deposits that Frame worked on, we've acquired new mineralogical and geochemical data on selected phosphate deposits and occurrences. We've also done quite a lot of work on the chemistry of apatite and igneous phosphate deposits, and have also prepared a procedure to prepare samples for analytical procedures to provide internally consistent geochemical data at a European level. We've established the concept of metallogenic areas for several critical elements in Europe. Now, metallogenic areas are extremely important because not only do they give you a specific area where the deposits are likely to occur, and obviously increase the range of the areas where you are likely to find these deposits. For example, on the slide you have the lithium metallogenic areas, and obviously the separated into class types, obviously, and so those areas in orange, yellow, and the pinks represent areas where you are most likely to find new lithium deposits. The bilateral collaboration between Frame and MineSea that I've spoken of before has resulted in the production of land sea maps containing phosphate and cobalt, and this is an example of the European cobalt mineralization on both land and sea. And for the first time, we have done away with the frontiers between the land and sea, which is extremely important. One of the innovative aspects in mineral intelligence that Frame has also done is obviously the predictivity and favorability mapping. Now, favorability and predictivity mapping stack a whole set of information to produce areas, as you can see exemplified on the left-hand side of the screen, where you are most likely to also find deposits of a specific type. So in the red, you have areas where we have known deposits, and this is the information that has been really the core to generating these maps. And obviously, as you move away from the red areas to the white areas, your chances of finding deposits of this type, in this case lithium, become increasingly less. And so one thing that you have to take care to note is that although the areas are white and at first you are not likely to find any lithium deposits, as the example shows. In this case, you must remember that this is because we still don't have any information on those white areas. Were we to find some information of lithium deposits in those white areas, it would obviously change the appearance of this map dramatically. Another impact that FRAME has had is the compilation of new incomplete data on lithium, cobalt, and graphite, namely the battery critical elements. It has also classified the lithium type deposits into brine, hard rock, magmatic lithium, magnetic hydrothermal lithium, and sedimentary hydrothermal lithium, which was not done before. It has also separated the European graphite deposits into the so-called flake and amorphous type of deposits. And also for the first time, it has compiled in an aggregated form the occurrences, geology, and potential for lithium, cobalt, and graphite. And for the first time, it was possible to make clusters of deposits and also define metallogenic provinces for most of Europe. Looking at the niobium, tantalum deposits, FRAME carried out and looked at the conflict minerals, which are in this case niobium and tantalum, well ahead of the EU legislation, and did a comprehensive characterization of the European and African niobium tantalum deposits. It has generated new petrographic and quantitative mineral chemical analysis, and has also identified a set of niobium tantalum minerals that you can see listed in your screen right now. In terms of the historical mines and the work done in the historical mines, obviously this work was severely impacted by the pandemic situation, and a lot of the field work could not be carried out. Nevertheless, FRAME still managed to collect data from 160 mine sites, and also specific case studies were undertaken in a dozen old mines. Together with GIP and Mintel4U projects, we've implemented important issues in a global context of the World System of Information. This includes an integrated results through the EGDI portal, and also FRAME was instrumental in the improvement of the present harvesting system and its quality assurance. Now, FRAME has also augmented and updated the European data sets, namely in this case EGDI, which is probably the most important, and has added in excess of 135 new documents to this platform. One of the things that FRAME has done on innovative scale is really that we have moved away from point data to area data. Now, this makes future exploration and prospection much easier, because you now have larger areas in which to look at, and you are not confined to a specific point on the map. In terms of a concluding remark, I would like to say that FRAME has made a significant attempt to further unlock the mineral potential for a renewed raw material sector in Europe as a driver for domestic raw material value chains. And with this statement, I thank you very much for listening.
Thank you very much, Daniel. We will collect also some questions later on, and you might also see some questions already coming up. But now we will continue with Euroletters, and the speaker will be Tom Helder from the Norwegian Geological Survey, and he will be supported by our colleague Kostas Laskaridis from the Hellenic, also from the Greek Geological Survey. Sorry. So, Daniel.
Yeah, thank you. Yeah, good morning, and I will speak about not a critical material, but a highly important material for the green transition. So I will also, like Daniel, I will ask you to start the presentation. Good morning. My name is Tom Helder, and I will present project Geolitos, Ornamental Stone Resources in Europe, on behalf of the project team. First, I will try to inform you a little bit of why we started this project. And I will start with some quotation presented in an article in The Guardian in 2020. It's cheap, light, quick, fireproof, and has a tiny carbon footprint compared to concrete. No wonder the great forgotten material of our time is staging a comeback. So this new miracle material, which is a sustainable product in architecture, is stone, which we can say are dimension stone, ornamental stone, which basically means the same. So ornamental stone is a durable and high quality construction material. It has not run out of fashion for 5,000 years. It represents a phase of our cultural and architectural heritage. And it's locally or regionally available all over Europe. Even today, ornamental stone production creates a large amount of jobs in Europe. Another important aspect is that ornamental stone has less climate impact than most other non-organic construction materials. Europe has a large diversity of stone materials, has a large number of unique resources with long history, has workforce and skills to exploit the resources, but in Europe there is a lack of a harmonized information platform, and there is a lack of proper tools for value assessment beyond the short-term economic. That is what we try to answer in Geolitos, to get these resources on the map and provide tools for proper resource management aid. Who are we in Geolitos? We have had a partnership with 15 partners in 14 countries. I, representing the Geological Survey of Norway, have been project lead, and in addition to the Geological Survey of Norway, we had work package leaders from Portugal, Greece, and Croatia. Geographical coverage of the project is what is marked in this figure as a dark blue color. There are also other in addition, there are other countries in taking part in the GeoERA consortium, and we hope that they also will follow following the guidelines for how to deliver ornamental stone data in the future. So what has Geolitos made? What is the result of this project? First of all, and most importantly, it is maps and databases. So we have developed a harmonized way of presenting information about ornamental stone resources, and we have produced maps like the one you are seeing here, representing unique ornamental stone types in Europe. This map, which you can find on the GeoERA website and also at least in short time span in short time in the EDDI, you will have information about a number of ornamental stone resources in the partner countries. You can get tabular information by clicking on the points, such as unique names commodity, lithology, and even color, and which places these resources are found. For a number of these resources, you can also follow a link to EGGI database, where you can find more information about these resources. So in total, we have 1,220 unique stone types on the map. 350 of them are linked to detailed reports. This database will grow after the project end. We will continue this work. It does not stop after GeoERA stops. We have also delivered a range of other projects, such as a number of country atlases and one regional, where you can find an introduction of ornamental stone production and history in these countries, and you can also find detailed information about resources. We have produced a number of case studies, in a way trying to highlight what we would say is non-economic value assessment and best practice for the management of ornamental stone resources. It's not only the economic value that is important, but for land use planners, municipalities, regional authorities, and even national authorities, the methods in a way to illustrate non-economic values can be significant for securing future production, for instance. And such values can be, for instance, the architectural heritage connected to a specific resource. We have also produced newsletters that has been sent to an address list of about 150 and also published on the web. And we have a number of deliverables that in a way are explaining how to harmonize, how to provide data, etc., and including guidelines for assessing non-economic value of ornamental stone resources. Plus, we will publish a scientific volume, Geological Survey of Norway Bulletin special publication, and we recently had manuscript deadline, and we will publish a number of papers based on the case studies and atlases within a short period. Where can you find information about us? If you Google Eurolitos, the first hits will be the project-related information. You have the project web, the GeoERA web, or the project on the GeoERA web, Facebook, and Twitter. The project web is easy to find, eurolitos.org, where you'll find a collection of results and a gallery of ornamental stone resources, etc. On the GeoERA website for the project, you will find the map I was referring to. And Facebook and Twitter information is also available. And then we comes to what to do with Eurolitos after GeoERA. Can we continue this work? Geological Survey of Norway will provide regular update services for map and directory for 5 years. We will also maintain website and in a way, transform the project web to Eurolitos community. And we will also welcome contribution of new data and new countries for participating in delivering data in the time to come. I was end my presentation with taking a few examples, just practical examples, like Mocha Cream limestone from Portugal. It's a beige limestone, and through the geolithos you can find the information about the geological setting of this limestone, extent of the resources, where the quarries are. You will find information that this limestone is used all over the world in a large number of buildings. You will find information about the petrography and microscopic images, and you can get access to physical properties analysis, and also where you can find more information about this particular resource. Another example is from Greece, the Styra green marble, which has been produced all the way since antiquity. You can find geological maps and examples of use, in this case the Hadrian's Library in Athens, microscopic information and petrography, and chemical properties, geochemistry. The third and last examples, dark lavicite from Norway. This is a dark blue igneous rocks with this play of colors in the crystals. I think most of you have seen it, and it's also applied all over the world. So you'll find a geological map and where this particular resource is found, examples of use, microscopy, photographs and descriptions, and in this case I just put up the mineral composition table. So we think we have met the goals of providing a harmonized information system for ornamental stone resources in Europe. And we have also created a system that can continue after the project, and we will make sure that it is possible to deliver data and to upgrade data in this for a long time to come. Want to take part? Please contact me. And I will thank you for listening with some photos from project meetings before the COVID-19 started. Thank you for listening.
Thank you very much, Tom, also for these beautiful insights to mineralogy. And now we will continue with the last presentation in this session, which is about Mintel for EU, and it will be presented by Lisbeth Flint Jørgensen from the Geological Survey of Denmark and Greenland. Lisbeth, the floor is yours.
Thank you, Antje, and thank you to all the earlier presenters and to all of you who are present. My video is also pre-recorded, and I'll ask Christian to run it in a few seconds. But I would also like to mention, on top of the presentations that have been conducted so far, that we have actually worked very closely together in the raw materials projects. We actually had weekly meetings since the COVID-19 started, so we met online. And this cooperation has actually contributed a lot to the database that we have built in Mintel for EU, where questions from the other project and requests and new data also has improved the database. So Christian, please run my presentation. As mentioned earlier today by theme coordinator Antje Wittenberg, the 4 GeoERA raw materials project delivered a number of products that are first of their kind. Among these are a combined database with data on mineral occurrences and mines, as well as on production, trade, resources and reserves, national atlases on ornamental stones, compilation of occurrences, geology and potential for a number of critical raw materials, pan-European maps on marine deposits, pan-European productivity maps on marine and landlocked critical raw materials. In the next slides, I will present the project Mintel for EU. Mintel for EU, or Mineral Intelligence for Europe, built on a number of previous projects as Minerals for EU and others, and cooperated with parallel activities in Reservé and Orama. Our aim was to support responsible domestic sourcing in Europe by making raw material data available in a harmonized and INSPIRE-compliant way for policymaking, for subsurface planning and management, for investments, as well as for the general public. While collecting comparable and reliable raw materials data, we have updated, extended, and further harmonized European data on mineral occurrences and mines, also known as the Minerals Inventory. Data are collected from national databases hosted by individual data providers, but first data are organized in a harmonized and INSPIRE-compliant way. We can now present data from 31 countries, and huge efforts have been put into automate the collection and updating of data by a harvesting system that offers a number of electronic routines to support the data providers. Data are stored in a central database called Min4EU that is an integrated part of EGGI, the European Geological Data Infrastructure. Data from Min4EU are visualized in interactive maps at the EGGI viewer. Let's have a look on how these data are visualized at EGGI. This map shows the geographical coverage when it comes to mineral occurrences, occurrence areas included, as some providers have shared data as polygons. If we zoom in, here Ireland, and click on a single occurrence, we get more information. We can also select a single commodity, here zinc, or even more different commodities if we wish. The level of information on points level may change from country to country, but the available data are harmonized and comparable. Not all occurrences are quantified, but in this RX example they are, and we can choose to only see occurrences of medium to large importance. We have also created predefined maps that we think are interesting to certain stakeholder groups, like this one showing the critical raw materials occurrences in Europe. This map shows the coverage with respect to mines, closed as well as operating or under development. Actually, there are so many mines in the database that they must be clustered in a view like this, so let's zoom in, this time on the Fennoscandian area. Again, if we click a point, here mine, we get more information. As with the occurrences, it is possible to select in the menu to the left, per commodity, and mines can also be sorted per operational status and per mining activity. Another task in Min4EU was to collect information on historic mines with touristic features, a task that caught more partners' attention than originally planned, and at this map almost 500 sites are listed. If you click on one of the sites, more information appears, among other things a link directly to the webpage of the chosen mine. Tourist mine sites are important in communicating to the general public and strongly supports the understanding of the importance of former and possible future mining activities in Europe. In Min4EU, we have also updated the European Electronic Minerals Yearbook that now offers time series for 60 commodity types covering the period from 2004 until 2019 on production in 40 countries, as well as trade data in 36 countries over the period from 2004 until 2018. Besides, 20 countries have supplied data on reserves and resources with a reference year of 2019. These data are also stored in Min4EU and visualized at EGGI. Let's have a look at the Electronic Minerals Yearbook in EGGI. Here you see the 2019 production of the 4 battery raw materials, lithium, cobalt, graphite, and nickel, in these 4 maps. Time series might be even more interesting, and here we can see a map of copper producing countries as well as time series on production, export and import that of course can be selected per one or more countries as well. Actually, a layer from the minerals inventory dataset showing copper occurrences has been overlain this map, and the maps get more interesting when the data are combined. There are mutual opportunities, and I can only encourage you to try yourself and to listen to the presentation of the GIP project later today, as this project has added all data produced in GeoERA to the EGGI platform and will show some examples on how data can be combined. We have generated a small video for you, if you are a bit patient, walking you through the years from 2004 until 2018, showing the development in copper export in Europe. The color changes as it reflects how much each individual country exported compared to the other countries in the same year, and quantities are indicated by a number in each country. Besides, a stationary time series is shown in the lower right corner, actually showing the same, just in another and more compensated way, where it's difficult to distinguish between countries. Data on resources and reserves were collected through an online survey. Unfortunately, not all partners were able to contribute with data, partly due to data accessibility issues. However, more than 20 countries supplied new data marked in orange in the maps below, with a reference year of 2019, and at EGGI, resources and reserves data collected in the Minerals for EU project with a reference year of 2011 to 13 are also available. These are the yellow countries in the maps. In the next slide, you will see more countries that provided new data in Minerals for EU, but organized in accordance with the United Nations Framework Classification System that you will hear more about in a minute. This altogether provides a regional spatial coverage of Europe, time-wise representing the last decade. As with the other maps, click on a country, here Sweden, and a box with more information appears. For 8 countries, data providers actually chose to deliver data compliant with the UNFC code. In the menu to the left, commodities as well as project matureness can be selected, and by clicking a country, here Greenland, you get more information on what commodities were reported and the level of socio-economic viability. In this case, the list below is much longer than this view can contain, both to the right and downwards, but of course when you are at the map you can scroll. When comparing data across borders, you need harmonized data as well as a uniform classification system. We have performed a pilot testing the United Nations Framework Classification System on raw materials with test cases on different commodities in 9 countries, and a map showing where these are can be found at EGGI. Based on this pilot, a number of challenges and recommendations have been compiled. The pilot on the UNFC system included 19 test cases covering 30 commodities as shown in the table below. The map at EGGI links to the relevant output report. A try was also given to develop visualization of UNFC codes as illustrated in the middle of this slide. The experienced challenges resulted in a number of recommendations for future efforts to further implement the UNFC system on European raw materials. Among these are that national and international policy frameworks are needed to overcome poor data availability and sharing in suitable interoperable formats. Besides, data compilation and classification procedures and UNFC reporting templates must be developed to improve quality and facilitate automation. Furthermore, extensive training is required to overcome the lack of common understanding of the UNFC system and make the results more transparent, comparable, and reliable. These issues are foreseen to be addressed in the future CSA program. Finally, the sharing of data was an overarching and mandatory task, and the full Min4EU database is downloadable through EGGI, and data can be reused respecting the associated licenses. Besides, we also share our data with the Raw Materials Information System established by Joint Research Center ISPRA under the Commission, and test towards sharing data with EPOS, the European Plate Observing System, was also initiated. As you can see, a broad range of activities were undertaken in this project, and all of this would of course not have been possible without the active contribution from the 27 partners, as well as other parties and countries that decided to join along the road. Thank you for listening to this presentation, and thank you to all the partners participating in Min4EU.
And thank you also to you, Lisbeth, for this comprehensive overview of this very complex project. May I also ask all the speakers and the work package readers available to put on their cameras. So if there are any kind of questions, we can answer it now. We still have a few minutes to go. So there's one question also in the chat box, which is frame. Is there any kind of idea to develop or improve tools and technological developments for metallogenic recovery of lithium, niobium, tantalum, phosphorus, cobalt, or other critical raw materials? So,
Yeah.
Danielle, can you answer that, please?
Yeah, sure. Thank you very much, Javier, for that question. Don't forget, as you also answered my question, that we have the next GSEU project coming up, and that project is obviously going to be looking into these elements once more, and it's going to be looking at them obviously from a different perspective, and also using updated tools. So that is what's going to be happening in the next 5 years.
Thank you.
Thank you very much. Are there any other questions from the attendees? So as we have also Kari Astley with us, she was the work package leader for the UNFC part, which is quite important challenge for the future. And we also have that Lisbeth can add something on the CSA as well. Please, Lisbeth.
Yes, I just put a comment in the question field that, of course, the tasks on collecting data for the minerals inventory and the European Electronic Minerals Yearbook will continue in the CSA, which we, of course, need to add. It's not granted yet. We have an application, which we hope will have a nice review at the Commission. So, but if we start the CS program in later this year, all these tasks that we carried out in Mental for EU will be continued.
I don't see any further questions, but I know that we are running out of time, which was really a challenge. All these very, let's say, these fruitful presentations and fruitful cooperation within GeoERA was quite extensive piece of work, and I thank all the participants who have provided huge efforts in order to make everything happen. I know it was a big challenge under this given circumstances, and I thank you once more for this one. And I also thank the attendees for listening to us, and please be welcome also to have a look at their distinctive size of the projects. There are much more to, let's say, to explore. And I hope to see you soon again at a different kind of circumstances alive. Thanks a lot. And here I close this session.
Bye.
Bye, everyone.
Bye-bye, everybody. And thank you, Antje.
Thank you,
Thank you,
Antje.
Elizabeth. Thank you, Tom. Thank you, Javier.
Thank you very much.
Kari, Costas. That was great. GeoERA raw materials rules.